Good morning! Today we will learn how to solve quadratic equations by factoring. We have learned that a quadratic equation written in the form x squared is equal to k can be solved by extracting the square root. Remember, if k is greater than 0, the quadratic equation has two real solutions or roots. If k is equal to 0, the quadratic equation has one solution or one root, and that is equal to 0. But if k is less than 0 or if k is a negative number, then the quadratic equation has no real root or no solution. Okay, letter A, we have 3t squared is equal to 12. First, we write the equation in the form x squared is equal to k. So in order to do that, we divide both sides of the equation by 3. So we have t squared is equal to 4. Now, our quadratic equation is written in the form x squared is equal to k, where k is equal to 4. 4 is greater than 0, then this quadratic equation has two real roots or two solutions. Now let us solve it by extracting the square root. The square root of t squared is t, and the square root of 4 is positive and negative 2. Therefore, the roots or solutions of the quadratic equation are positive 2 and negative 2. Let's proceed to the next one. We have x squared plus 7 is equal to 0. First, write the equation in the form x squared is equal to k. X squared is equal to negative 7. We transpose positive 7 to the right side of the equation. Now, our equation is written in the form x squared is equal to k. Our k is equal to negative 7. Since k is less than 0, then this quadratic equation has no solution or no real root. Because there is no number which when multiplied by itself will give us negative 7. Let's proceed to letter C. We have quantity s minus 4 raised to the second power minus 81. First, write the equation in the form x squared is equal to k. So we have s minus 4 raised to the second power is equal to, transpose negative 81 to the right side of the equation. So it becomes positive 81. Now, our quadratic equation is written in the form x squared is equal to k. Our k is equal to 81. 81 is greater than 0, so it means that this quadratic equation has two solutions or roots. Now, let us solve by extracting the square root. So, the square root of quantity s minus 4 raised to the second power is s minus 4. And the square root of 81 is positive and negative 9. Now for our solution, first solution, we have s minus 4 is equal to positive 9. For the second solution, we have s minus 4 is equal to negative 9. Let us now solve for the values of s. S is equal to 9 transpose negative 4 to the right side of the equation. So we have 9 plus 4. S sub 1 is equal to 9 plus 4, we have 13. And then for the other solution, we have S is equal to negative 9 transpose negative 4 to the right side of the equation. So we have negative 9 plus 4. Therefore, S sub 2 is equal to negative 9 plus 4, we have negative 5. So the two solutions or roots of the quadratic equation are 13 and negative 5. Now, so we have learned that if a quadratic equation is expressed in the form x squared is equal to k, it can be solved by extracting the square root. Now this is the question. How would you solve this kind of quadratic equation? X squared plus 9x plus 20 is equal to 0. Okay, we can solve this kind of quadratic equation by factoring. So this is another method of solving quadratic equations. Before we learn how to solve quadratic equations by factoring, let us first refresh our memory on some factoring techniques. So when you were in grade 8, you have learned these different factoring techniques. So let's have a short review. First, we have factoring by common monomial factor. Say for example, we have 12x squared plus 18x. So we can factor this by getting the GCF of 12x squared and 18x. So what is their GCF? Their GCF is 6x. Now, 12x squared divided by 6x is equal to 2x. Positive 18x divided by 6x is equal to positive 3. Now the answer is 6x times quantity, 2x plus 3. You can check your answer by applying distributive property. 6x times 2x is equal to 12x squared. 6x times 3 is equal to 18x. So our answer is correct. Next, we have 14x squared minus 35x. What is the GCF of the two terms? So their GCF is 7x. 14x squared divided by 7x is equal to 2x. Negative 35x divided by 7x is negative 5. Therefore, the answer is 7x times quantity, 2x minus 5. So let us check if our answer is correct by applying distributive property. 7x times 2x is equal to 14x squared. 7x times negative 5 is equal to negative 35x. Let's have the third one. X squared plus 4x. What is their GCF? Their GCF, or greatest common factor, is simply x. Now, divide the first term by x. X squared divided by x is equal to x. Positive 4x divided by x is equal to positive 4. So, let's check. X times x is equal to x squared. X times 4 is equal to 4x. So, this is correct. Next, we have factoring general quadratic trinomial. First, we have x squared plus 5x plus 6. This is equal to, so what are the factors of x squared? We have x and x. For 6, we need to think of the factor pairs of 6. What are the factor pairs of 6? We have 1 times 6 and then 2 times 3. Among the factor pairs, which will give us 5 when added? That is 2 times 3. Therefore, we have x plus 2 and x plus 3. To check, we multiply the inner terms and the outer terms. 2 times x, 2x. X times 3, we have 3x. If you add the 2, it must match the middle term. Since it matched the middle term, therefore, these are the correct factors of x squared plus 5x plus 6. Okay, let's have the next one. X squared plus 2x minus 13. First, let's have x squared. X squared is equal to x times x. We have negative 8 here. Now, what are the factor pairs of negative 8? It could be negative 1 times 8, negative 8 times 1, negative 2 times 4, or negative 4 times 2. Among the factor pairs, choose the pair which will give you positive 2 when added. So which will give us positive 2 when added? That is negative 2 and positive 4. So we have positive 4 and negative 2. Let's check. 4 times x is 4x. X times negative 2 is negative 2x. So if we add them, we get 2x. And that is equal to the middle term. So meaning that the factors of the trinomial are x plus 4 and x minus 2. Number 3, we have 2x squared plus 5x plus 2. We can use trial and error method. So for the first term, what are the factors of 2x squared? It can be 1 times 2 or 2 times 1. And then for 2, we have also 2 times 1, 1 times 2. Let's first try 2x squared times x, and then, so I will choose this and this one. Let's check. 2 times x is 2x. 2x times 1 is 2x. So if we add the 2, that is only equal to 4x. So as you can see, it did not match the middle term. So therefore, this is not the factor of the given trinomial. So we will try another one. 2x times x. Okay, let us change the positions of 2 and 1 here. So let's try 1 here and 2 on the next factor. Okay, so 1 times x is 1x. 2x times 2 is 4x. When added, that is equal to 5x, which match the middle term of the trinomial. Therefore, these are the factors of the given quadratic trinomial. Let's have the next one. Next, factoring perfect square trinomials. Perfect square trinomials are actually results of squaring a binomial. So if we have x squared plus 6x plus 9, what are the factors? We have you simply get the square root of the first term and the square root of the second term. So this is x plus 3 raised to the second power, or in expanded form, that is x plus 3 times x plus 3. Number 2, x squared minus 2x plus 1 is another kind of perfect square trinomial. Again, it is simply the square of a binomial. So we have the square root of x squared is x, and the square root of 1 is 1. Copy the sign, so we have x minus 1 raised to the second power, or in expanded form, that is x minus 1 times x minus 1. Next, we have x squared plus 20x plus 100. Again, it is a perfect square trinomial. It is the factors are simply the square of a binomial. So the square root of x squared is x. The square root of 100 is 10. Based on the given sign of the middle term, so this is positive. In expanded form, we can also say this is x plus 10 times x plus 10. You can check your answer by multiplying this using FOIL method. The product must be equal to the original equation. Next, factoring the difference of two squares. Remember that the factors of the difference of two squares is simply the sum and difference, or the product of the sum and difference of two terms. It is simply the product of the sum and difference of two terms. So this is, get the square root of the first term and then the square root of the second term. We have 6. Product of the sum and difference of two like terms. Next, we have 4x squared minus 36. So this is 2x and 2x. Sum and difference, the square root of 36, we have 6. So the factors are 2x plus 6 and 2x minus 6. Next, 4x squared minus 81. 4x squared, the square root is 2x. The square root of 81 is 9. So we have the sum and difference. 9, 9. Therefore, the factors of 4x minus 81 are 2x plus 9 and 2x minus 9. Now that you have recalled the different factoring techniques, you are now ready to solve quadratic equations by factoring. Here are the steps in solving quadratic equations by factoring. Step 1. Transform the quadratic equation into standard form if necessary. Step 2. Factor the quadratic expression. Step 3. Apply the zero product property by setting each factor of the quadratic expression equal to 0. Step 4. Solve each resulting equation. Step 5. Check the values of the variable obtained by substituting each in the original equation. So let's first have the zero product property. According to the zero product property, if the product of two real numbers is zero, then either of the two is equal to zero or both numbers are equal to zero. Say for example, we have A times B is equal to 0. According to zero product property, it's either A is equal to 0 or B is equal to 0. Let's have another one. Let's say x plus 2 times 2x minus 1 is equal to 0. By applying zero product property, we can say that x plus 2 is equal to 0 or 2x minus 1 is equal to 0. Let's now have example number 1. Find the solutions of x squared minus 9x is equal to negative 18. So for step 1, transform the quadratic equation into standard form if necessary. So to write it in the standard form, ax squared plus bx plus c is equal to 0, we need to transpose negative 18 from the right side of the equation to the left side of the equation. Therefore, the equation becomes x squared minus 9x plus 18 is equal to 0. Step 2, factor the quadratic expression. So what are the factors of x squared minus 9x plus 18? For x squared, we have x and x. Now for 18, let us list all the factor pairs of 18. So the factor pairs of positive 18 are 1 times 18, 2 times 9, 3 times 6. It can also be negative 1 times negative 18, negative 2 times negative 9, and negative 3 times negative 6. Now, among the factor pairs, which pair will give us negative 9 when added? Again, which will give us negative 9 when added? That will be negative 3 and negative 6. So we have here negative 3, negative 6. Let's check negative 3x plus negative 6x. The sum is negative 9x, which is equal to the middle term. Step 3. Apply the zero product property by setting each factor of the quadratic expression equal to 0. So the first factor is x minus 3. So we have x minus 3 is equal to 0. The second factor is x minus 6. So we have x minus 6 is equal to 0. And then step 4, solve each resulting equation. Solve for x. So we have x is equal to, transpose negative 3 from the left side of the equation to the right side of the equation. So it becomes positive 3. Next, we have x is equal to 6. So x sub 1 is negative 3, x sub 2 is positive 6. Check the values of the variable obtained by substituting each in the original equation. So the original equation is x squared minus 9x is equal to negative 18. Let us first substitute positive 3. 3 squared minus 9 times 3 is equal to negative 18. So we have 9 minus 9 times 3, 27, is equal to 18, negative 18. 9 minus 27 is negative 18. Is negative 18 equal to negative 18? Yes, since it is a true statement. Therefore, positive 3 is a solution of the quadratic equation. Let us try x is equal to 6. So in the original equation, x squared minus 9x equals negative 18. We will substitute 6 to x. So it becomes 6 squared minus 9 times 6 is equal to negative 18. 36 minus 9 times 6 is 54. It's equal to negative 18. Now what is 36 minus 54? 36 minus 54 is negative 18. Negative 18 is equal to negative 18. This is a true statement. So 6 satisfies the original equation. Therefore, it is a real solution of the quadratic equation. Let's have example number 2. Find the solutions of 4x squared minus 49 is equal to 0. First, transform the quadratic equation into standard form. 4x squared minus 49 is already written in standard form. So let's proceed to step number 2. Factor the quadratic expression. The quadratic expression is a difference of two squares. 4x squared is a perfect square. 49 is also a perfect square. So we have learned that the factors are the product of the sum and difference of two terms. So the square root of 4x squared is 2x, and the square root of 49 is 7. So this is simply the product of the sum and difference of two terms. So the factors are 2x plus 7 and 2x minus 7. Step 3. Apply the zero product property by setting each factor of the quadratic expression equal to 0. So equate 2x plus 7 to 0 and 2x minus 7. Solve each resulting equation. So we have 2x is equal to transpose 7 to the right side of the equation. It becomes negative 7. Divide both sides by 2. Therefore, x is equal to negative 7 over 2. This is x sub 1. Next, we have 2x is equal to transpose negative 7 to the right side of the equation. And then, divide both sides by 2. Therefore, x sub 2 is equal to positive 7 over 2. Therefore, the two roots or solutions of the quadratic equation are positive 7 over 2 and negative 7 over 2. Step 5. Check the values of the variable obtained by substituting each in the original equation. So the original equation is 4x squared minus 49 is equal to 0. Let us substitute negative 7 over 2 to x. So we have 4 times 7 over 2 squared is 49 over 4 minus 49 is equal to 0. So we can simply cancel 4 here. So we have 49 minus 49 is equal to 0. 0 is equal to 0. So it satisfies the given equation. Same will happen to negative 7. If we substitute negative 7 over 2, if this is negative 7 over 2, still that will give us positive 49 over 4 when squared. So cancel 4, 49 minus 49 also is equal to 0. So both solutions satisfy the original equation. Example number 3. Find the solutions of 3x squared minus 4x is equal to negative 1. So step 1, transform the quadratic equation into standard form if necessary. So we will move all terms to the left side of the equation. We now have 3x squared minus 4x plus 1 is equal to 0. Step 2, factor the quadratic expression. So for 3, the factors are 1 times 3 and 3 times 1. For 1, the factors are 1 times 1. But since the middle term is has a negative sign, it can also be negative 1 times negative 1. Okay, so let's say we choose 3 times 1, so 3x times 1x. That is 3x squared. And then for 1, we have negative 1 times negative 1. So negative 1 times x is negative x. 3 times negative 1 is negative 3x. When added, it will give us negative 4x, which is equal to the middle term. So therefore, these are the factors of the given trinomial. Don't forget to bring down is equal to 0. Next, apply the zero product property to the two factors. So we have 3x minus 1 is equal to 0. And then for the other factor, we have x minus 1 is equal to 0. And then so for x. So 3x is equal to 1. Divide both sides by 3. Therefore, x is equal to 1/3. This is our x sub 1. And then for x sub 2, we have x is equal to, transpose negative 1 to the right side of the equation. So we have positive 1. Next, check the values of the variable obtained by substituting each in the original equation. So the original equation is 3x squared minus 4x is equal to negative 1. So let's first try to substitute positive 1/3. 1/3 squared minus 4x is equal to negative 1. So this is 3 times 1/3 raised to the second power is equal to 1/9 minus, 4 times 1/3 is equal to negative 1. And then we have 3 times 1/9 is equal to 3/9 minus 4 times 1/3 is equal to 4/3 is equal to negative 1. Let us simplify 3/9. 3/9 in simplest form is 1/3. 1/3 minus 4/3 is equal to negative 1. So that is 1/3 minus 4/3 is negative 3/3 is equal to negative 1. Negative 3 all over 3 is equal to negative 1. Negative 1 is equal to negative 1. So 1/3 satisfies the given quadratic equation. Therefore, it is a real solution of the quadratic equation. Let us try now with x is equal to 1. So again, let us substitute 1 to the original equation. The original equation is 3x squared minus 4x is equal to negative 1. So let us substitute 1 to x. Three times 1 squared is 1. Negative 4 times 1 is negative 4. 3 times 1 is 3. Minus 4 is equal to negative 1. 3 minus 4 is negative 1. Negative 1 is equal to negative 1. So this is a true statement. Therefore, 1 satisfies the original equation. Therefore, the two solutions of the quadratic equation are 1/3 and positive 1. Okay, solve the quadratic equation by factoring. Okay, let's have it one by one. Number 1, we have 2x squared minus 6x is equal to 0. So first, we will factor this given expression by common monomial factor. So what is the GCF of 2x squared and 6x? Their GCF is 2x. 2x squared divided by 2x is x. Minus 6x divided by 2x is equal to 3. Let's check. 2x times x is 2x squared. 2x times negative 3 is negative 6x. Next, apply zero product property. Equate both factors to 0. 2x is equal to 0. X minus 3 is equal to 0. And then solve for x. So to solve for x, divide both sides by 2. X is equal to 0 divided by 2, 0. So our x sub 1 is 0. And then on the other one, we have x is equal to, transpose negative 3 to the right side of the equation, so we have positive 3. So the two solutions of the quadratic equation are 0 and positive 3. You can do the checking if you want. Next, x squared plus 22x plus 121 is equal to 0. The trinomial x squared plus 22x plus 121 is an example of a perfect square trinomial. Remember that the factors of a perfect square trinomial is simply the square of a binomial. So what are the factors? So the factors, here we have x plus 11 raised to the second power, or in expanded form, that is x plus 11 and x plus 11. Next, apply zero product property or equate both factors to 0. So we have x plus 11 is equal to 0. X plus 11 is equal to 0. Solve for x, therefore x is equal to negative 11. Here we will also get negative 11, which means that the quadratic equation has only one solution, and that is negative 11. You can check if your answer is correct by substituting negative 11 to the original equation. Let's have another one. Next, we have x squared minus 5x is equal to 24. First, let us express the quadratic equation in standard form. So we have x squared minus 5x minus 24 is equal to 0. And then factor x squared minus 5x minus 24. For x squared, we have x times x. For 24, let us first list the factor pairs of 24. We have 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Now, for the middle term, we have negative 5. Which among the factor pairs will give us 5 when added or subtracted? That will be 3 and 8. 3 and 8. Now look at the sign of the middle term and negative 24. We will choose between 3 times negative 8 or negative 3 times positive 8. Both of them, when multiplied, will give us negative 24. But when added, which will give us negative 5? So this pair will give us negative 5. So we have positive 3 and negative 8. To check, let us multiply the middle terms. So we have 3x. Multiply the outer terms. So we have negative 8x. When added, that is equal to negative 5x, which is equal to the middle term. Now, let us apply zero product property. Equate x plus 3 to 0 and x minus 8. And then solve for x. So for x sub 1, we have negative 3. For x sub 2, we have positive 8. So the two solutions of the quadratic equation are negative 3 and positive 8. You can do the checking by substituting negative 3 and positive 8 to the original equation. Next, let's have x squared minus 625 is equal to 0. If you will try to observe, x squared is a perfect square, 625 is also a perfect square. Now, this is a difference between two squares. So, how do we factor difference of two squares? It is simply the product of the sum and difference of two terms. So, what is the square root of x squared? We have x. The square root of 625 is 25. So, we have x for the first term and 25 for the second term. Express it as a product of the sum and difference of two terms. So we have quantity x plus 25 times quantity x minus 25. Next, apply zero product property. Equate both factors to 0. So we have x plus 25 is equal to 0 and x minus 25 is equal to 0. Solve for x. So x sub 1 is equal to negative 25. X sub 2 is equal to positive 25. You can do the checking by substituting negative 25 and positive 25 to the original equation. That is all for today. Thank you for listening.